Hey friends, hope 2A was a good time for you. Why would it not be? You know, we love working with units. Woohoo! We love it so much, we're going to do it again. And we're going to complicate it more this time. Or more advanced, excuse me. Last time was beginner level, this time we're doing advanced level. Okay, some things I just want to remind you of as you're going forward. This slide has a bunch of words on it. I want you to focus on this one. Make sure your answer has the units you expected. So I'm going to be doing a lot of, let's call it the train tracks, since you'll know what I'm talking about with that. I'm going to show it all through that way, and I need to make sure that my final answer ends with the units that I want. Something else I want to remind you is that per means division. And that should be enough to get us going. Okay. A car travels 25 miles every 23 minutes. How fast is it going? First question, what unit should your answer be in? How is speed measured? Miles per hour. That's what I want it to be in. Well, what the information I've been given is that we've been traveling 25 miles for every 23 minutes. Every could be replaced with per, and that's where that division is coming from. Okay, well, I need the bottom. My final answer, miles per hour, is going to be like miles over hour. So miles is already on top, so we're good there. But I need the denominator to be in hours. So I'm going to look at minutes here. Say, okay, well, I know there are 60 minutes in 1 hour. And I placed minutes on top, so then the minutes would cancel. And so now that just means we're going to do, this is like 25 times 60 divided by 23. You can do the times 1, but anything times 1 is just itself, so we don't really need that. I'm pulling out the calculator on my phone because that's what's right next to me. 25 times 60 and then divided by 23. So I get 65.22 miles per hour. Sweet. Okay, example 2. Let's say Eli purchased 5 pounds of apple at a price of 50 cents per pound. How much did he pay for the apples? Well, someone answers 50 divided by 5 and say 10. Pay 10 cents. First off, does it make a lot of sense to pay 10 cents for 5 pounds of apples? Probably not, but we need to look and see what happens. Well, 50 divided by 5, 50 cents per pound. Maybe he was doing, well, or she, we don't know. 50 divided by the 5 pounds, but that's not what we're needing to do here. If I have 50 cents per 1 pound, my final answer is how much are we paying? For my final answer needs to be in cents, which means I just need the cents. That means I gotta cancel out the pounds somehow. Well, that's because there are 5 pounds. Those cancel, and now we do 50 times 5. Which is 250 cents, or $2.50. Okay, the grocery store offers a small containers of basil. They are $2.99 for 2/3 ounce. But the farmer's market, you can buy basil in bunches for $12 per pound. So which is a better deal? Well, we know the farmer's market is already $12 per pound. So if I want to calculate the grocery store, it's $2.99 for 2/3 of a pound. Nope, ounce. 2/3 of an ounce. Well, I need it to be dollars per pound, which means I need pound to be on the bottom here. So I need to see how many ounces are in a pound. And just in case you don't know, 16 ounces are in a pound. Now my ounces cancel, so I'm going to go 299 times 16 and divide it by 2/3. Let's see, pulling up my calculator, 2.99 times 16 divided by, I'm going to turn it sideways and do the parentheses so I could do the 2/3. $71.76 per pound. Well, that seems a bit excessive. So as far as what's the better deal is the farmer's market. But let's talk about practicality. When might you use the worst deal? Here's the big question. Who needs a pound of basil? Really, though. You do this all the time, turns out, for all of your spice containers, because you just don't need that much. Okay, we're going to talk about more conversions. I would suggest writing, I would just write all of this down. So maybe pause your video for a moment and just, as far as what to write, you need this, and you need this. So joules, energy, powers, and watts. So pause it and write those down. Writing that down just so we can see it for this example. As you ride an exercise bike, the display states that you are using 500 calories per hour. So I'm just going to start by writing that. Are you generating enough power to light a 100-watt light bulb? So we're trying to end in watts. And I know watts is going to be a joule per second. Okay, look, one calorie is 4,184 joules. So when I want joules per second, that means I want joule over seconds. So we got the joules on top part, but right now it's joules an hour, so I need to convert the hours here into seconds. I'll do that in a different color. So hours needs to be to seconds, so I know 1 hour, 60 minutes. And then I know 1 minute is 60 seconds. So now I'm ending in joules per second, which is 1 watt. So how I type this in the calculator, I'm just going to go 500 times 4,184 and then divide it by 60 times 60. Just a word of warning, as you're doing this, as you type this into your calculator, anything in the denominator is like, you can either put it in parentheses or you can go 500 times 4184 divided by 60, and then you divide it by another 60. That shows that both of those are in the denominator. So just as an FYI, as you're typing that in, so 500 times 4184 divided by 60 divided by 60. 581.11 watts. which is the joules per second. And it's a 100 watt light bulb, so the answer is yes. That's a good example, and we're going to keep using it. Your utility company charges 15 cents per kilowatt hour of electricity. How much does it cost to keep a 100 watt light bulb on for a week? Okay, this is good. First, we need to know kilo. Kilo means 1,000. So if I have 15 cents per kilowatt hour, how much does it cost to keep 100 watt light bulb on for a week? Okay. Per kilowatt. Oh. I'm going to start with this. 1 kilowatt is 1,000 watts. So those cancel, and that's going to get me how much it costs per watt. Let's see, so move that decimal over. Okay, so it's very little per watt. But that's per hour. And so if we want to know how much was it in a week, there are 24 hours in a week. Sorry. Okay. I'm processing this in my mind still, so let me go this. Okay. Kilowatt hour. So I think they're both down there. So then 1 kilowatt. And now we have the hours. So I know there's 24 hours in one day. And there's 7 days in 1 week. Okay, there we go. Let's go with that one. Okay, so I'm going to go nope, try that again. 0.15 times 24 times 7. And looks like we just divide that by 1,000. .15 times 24 times 7 divided by 1,000. Wow, that is cheap. So, but it's a 100 watt light bulb. And we just did it. Oh, we're not done. Because that is in watts. Just single watts. But I have a 100 watt. So it's I'm not going to round it yet. Per watt per week. But now I'm going to times it by 100 because it's a 100 watt light bulb. That makes more sense. Okay. Sorry that was a little jumbled. I was figuring it out as we went, as one does. So, how much will you save if you switch to an LED bulb that provides the same light for only 25 watts of power. Well, if it's only 25, if 100 watts was 252, if I divide that by 4, that's going to get me to 25 watts. So I can divide this one by 4. And we get 63 cents. Okay, this is a lot of information, and it's taking me, like, this is my 3rd time teaching this class. No, this is my 4th time. It's taken me to the 4th time to really feel comfortable doing this, and you saw that even with the example 5, I was still having to think through it. So this is definitely a mental exercise. Feel free to email me if you're struggling on any of your homework questions. I'd be happy to help you. Let's see. I'm just trying to decide how much more I want to show you. We're close to being done, so let's just do these last 2. Okay, Manhattan Island has a population 1.6 million people living in an area of 57 square miles. What is the population density? That means that's population density is how many people per square mile. So 1.6 million per 57 square miles. Whoops. I'm just going to put that as miles squared. That means we'll just divide them. So 1.6 million, that's like 1/6, that's a comma. There we go. Okay, and our last example, hose fills a hot tub at a rate of 3.7 gallons per minute. So I like to write that down before I get started. How many hours will it take to fill that size hot tub? So this is what my final answer needs to be in. Okay, so minute, 60 minutes in 1 hour. I'm sorry, that was weird. $3.7 times 60. This is 222 gallons per hour. And so to cancel that, we need to know how long is it going to do. So 325 gallons and we divide it by 222. Okay, yep. I was just trying to stay consistent with the railroad track thing, but I feel like you needed to get to this rate to then know, okay, I have 325 gallons. So I'm just going to divide it by that rate. to get the per hour. Okay, like I said, this takes a little bit of getting used to. Here's this lovely meme to illustrate that. If you need help, please email me. Please let me know. We have plenty of class time where we can also work on this on Thursday. So if we need to start out Thursday by working through some problems, we can do that. Let me know how it goes.